I've been making some progress on my Kubernetes journey, and I want to share some of the things I've learned along the way with you all in case you guys are also interested in learning more about DevOps or backend. I'm going to hit on a lot of different topics in this video. I went ahead and brought in something called Minikube so I can have a cluster running locally. This is the Minikube UI that I might kind of go through for all you all. I brought in RabbitMQ, which is a message broker. I know a lot of people use Kafka as well, but I decided to keep it simple, brought in RabbitMQ. And then I have a higher level diagram built out so I can kind of explain to you all what my high level goals are for this project. I know there's a lot of things I could just bring in, like I could just bring in Redis for my key value store, but I'm trying to reinvent the wheel so I can kind of learn more about Kubernetes. So this is the overall application where I have some APIs and a user can store whatever key value combination they want inside of this API, right? So over here, step 0, a user does a post request to store some value at some key location. And so after the user makes a request, that hits the API, that gets stored in local memory cache. But I also brought in persistent storage so that I can write to a block storage device or just like a local /data directory, where I also write a JSON file to keep track of that key value as well. So it is persisted somewhere in case my cluster were to die, that data is not just gone. And it's also a mechanism for how we're sharing these key value stores with all the other nodes in the system. Okay, so right now in my cluster, I have 4 of these things running, so 4 of the APIs running. But if someone does a post request to, let's say, this API, how do we notify the other APIs that there is a new value stored inside of this block storage or this data directory? Well, I brought in a message broker, RabbitMQ, something I used a long time ago. I don't know if it's even used that much anymore. You leave a comment and let me know. If there's something better I should be using, let me know as well. I think Redis has PubSub built into it. Maybe I could have brought in Redis. I know Kafka is something that people do for streaming and events. But regardless, I just needed a way to basically publish a key. So you'll see here step 2 and validate the cache key. So basically after I store to disk and I overwrite the cache in this API, I publish an event on a topic, and that topic broadcasts that same event to all the other APIs in my system. And those APIs are subscribing to that same topic. So when they get that event, they basically go through and they invalidate their cache so that if someone were to do a GET request and it were to be load balanced and hit their API, it's going to go ahead and just force download the new value from this block storage, which is step 6. And then it's going to overwrite the cache here. And then the user will get the latest, greatest value. Okay, so that's what I have built out. And I'm going to walk you through some of the things that I've learned with getting this set up in Kubernetes. So the first thing I did was I needed to bring in something called Minikube because I was tired of deploying to DigitalOcean Kubernetes. It costs money and it's just, it's on the clouds, right? I'd rather have this stuff running locally if I could. So I brought in something called Minikube. For installing Minikube, I think it's just like a brew install Minikube. And then you can basically run it. And this is the Minikube dashboard. So this allows you to get insights into all your deployed pods. Notice here we have 4 of these key value applications running. I got a RabbitMQ pod running, which is where my message broker is hosted. You go down to persistent volume claims. You'll see I have one for RabbitMQ and I have one for key value app PVC, which is where we're storing those JSON files. There's also some secrets. So I learned more about secrets in Kubernetes. Basically, when I did a Helm install, which I'll talk about Helm in a second, I did a Helm install to basically install RabbitMQ directly into my cluster. And when you do that, you get some secrets that are defined for you. So the way Kubernetes works is it has a built-in like key value store for secrets and configuration. And if you want to grab those values and pass them to your Go application, you can do that inside your Kubernetes YAML files. Now, I don't know if there's anything else in here that I really want to talk about. Basically, I think that's kind of the gist of it. So let's first look at the Kubernetes deployment YAML. So the things I changed here to give us a persistent storage volume is I added persistent storage volume claim, or I guess it's called persistent volume claim, and I gave it 1 GB of storage. I'm not really sure about the access modes. Honestly, I use a lot of AI for helping me out with this, but basically I gave it read write once. And then over here inside of my Go deployment, where I have replicas for, I basically say, hey, I need you to be mounted to a volume and link to that persistent volume claim down here. And then up here in the container specification, we say, hey, I need you to mount that volume to /data. So in my Go code, I actually just look for /data/ whatever.json. And that's where I'm storing like those persisted key value files. And then I also define an environment variable. So this is how you can define environment variables in Kubernetes, and you can pass things into your Go program and load those in so that you know where exactly this volume mount's going to be. Some other things I'm passing in is the RabbitMQ host. So when I'm actually deployed to my cluster, this is what you can use for your URL. And then also the RabbitMQ password. So notice over here, I'm saying I need you to go into that my RabbitMQ secret object, which is here. And then I need you to grab this RabbitMQ password, which is down there. And that's how I'm basically taking that value that's in the Kubernetes cluster and I'm passing it to my Go program. So let's look at the Go program really quick. So when this program starts running, it listens to RabbitMQ. And what this method does is it basically creates a channel, which I'm trying to learn more about what a channel is in Go, but it seems like it's a way to just keep on getting events in and you can kind of respond to them. And then we declare an exchange. So basically we name an exchange called events, which is a type topic. And then I declare a queue, which is listening to that exchange, I believe. And I bind it down here. And then I finally run this for message in range messages, which keeps on processing events as they come in. So basically why I'm doing this is I have a post method, and every time a user tries to overwrite some data, I broadcast an event right here, publish event. I use that event's key, and then I also publish the cache key. So what this does is it sends an event to RabbitMQ. RabbitMQ broadcasts that to every single API in my system, and those APIs will all mark that value as dirty so that next time someone does a request on that particular API, it'll fetch the latest values from disk. Another thing I added in was basically persisting the disk. Remember in that diagram, it's writing to a volume mount. Well, here's basically how I do it. I am getting that prefix from the environment variables, and then I write that JSON to that file path here so that it's storing files for those keys. And then later on, when we do a get, I basically check if it's not in the cache, then go ahead and try to load it from the file. If there is no file, then go ahead and just return null. If the cache is dirty, go ahead and clear it out. And we also load that from disk as well. And then finally, we return that value to the user, right? So if I go down here and I do a post request to store some value, notice that we stored name of nope. I do a get request, and that is going to fetch that back, and we can send that back to the user. So I talked about how I set up the persistent volume claim, which allows us to kind of share some storage location between all of my nodes. I talked about how I set my Go program to read and write from disk and read and write from RabbitMQ. The next thing I kind of want to talk about is RabbitMQ itself. So if we go over to this RabbitMQ dashboard, you can actually see what nodes are connected to your RabbitMQ centralized message broker location. And as the APIs are kind of sending events, those get broadcasted to all the other channels listening. And I don't really know the dashboard too well here, but you can kind of dive into it and get more information about how this is all working. Here is my events topic. If I click that, you can see that some events get published. Okay, so now if I go to Minikube, again, let's go to my pods and let's just pick any of them. And I'm going to go ahead and view the logs up here. And I'm going to go ahead and just hit my endpoint a couple times. So let's go over here. I'll do a post request like this. And notice that it does print out setting cache as dirty at the bottom down here. And at some point, it's doing load balancing, right? So it's going to hit all these different nodes, you know, with like a round robin approach probably. But at some point, it should hit this node if I just do post enough. There we go. And so it happened to hit this node. And again, this node is basically saying, hey, I'm going to go ahead and take that value that was passed in. I'm going to write it to that JSON, testing.json file. And then I'm going to publish an event called testing on the topic's events so that all the other APIs in the system can mark that as dirty. And then if I do a get request, I should get back the latest value. So if I go over here and do a get and just hit that, we'll get back that value of nope. If I change it with a post and do a get, doesn't matter what server it hits, it's always going to get back that value if I do it fast enough, right? Now, again, this is an eventually consistent system. If you go back to the diagram, there is some delay between this API publishing an event and all the other APIs responding to that event and marking this cache as dirty. So there is some possibility that you'll write some cache value and then someone will do a get request and still get the old stale value. All right, the very last thing I want to talk about before I wrap this video up is I use something called Helm to install RabbitMQ. So I don't know too much about what Helm is, but it sounds like it's a way to basically take a collection of YAML files that someone else already wrote and apply it to your cluster. So all I had to do is basically run this command to add this Bitnami, whatever this is, this URL to somewhere in my cluster. Again, correct me if I say anything wrong. And then I run Helm install, which basically provision and set up all of those different pods that we saw, right? So these pods, literally I ran 2 commands and now I have a RabbitMQ cluster running, and it also prints out a bunch of information about how I can get the password from this deployment, how I can connect to it locally, how I could forward some ports locally. So when I'm doing local development, I basically run these port forward commands, and then I run my Go server locally in my terminal so that it can also share that RabbitMQ service when I'm doing local development. But when I deploy, I actually need to point it to this URL that it kind of prints out for me. So a lot of new things that I'm trying to understand and wrap my head around, but I feel like I have a better understanding of like Kubernetes and just setting up these systems and deploying them. It's pretty cool. I like it. Anyway, that's all I wanted to share with you all. If you do have something that you want me to talk more about or learn more about and maybe make a video about it, let me know. Leave a comment. And like always, I have a Discord channel. You guys are welcome to join. If you want to find a place to kind of hang out and talk to some other developers or message me directly, you can find the link in the description. Have a good day and happy coding.